Look up at the night sky. For more than 50 years, the moon has felt like a symbol of the past, something we remember through old photos, grainy video, and the glory of Apollo. That just changed. America has gone back to the moon, and this time, we are not just going to visit. We are learning how to stay. That is what the Artemis program is all about, and at the center of it is Artemis II, the first crewed mission in NASA's return to deep space, and one of the most important space flights of our generation. Now, you might ask, didn't we already go to the moon? Why go back? Because this time, the moon is not the finish line. It is the launch pad for what comes next. If humanity wants a future beyond Earth, we have to learn how to live on another world. Earth is home, but it is also vulnerable. History proves that. One asteroid changed life on this planet forever. If we want civilization to survive long-term, we cannot keep all of humanity in one place. That is why NASA, its international partners, and America's private space industry are heading back to the moon. The last humans walked there in 1972 during Apollo 17. Since then, no one has gone beyond low Earth orbit. Artemis II changes that. On April 1st, 2026, 4 astronauts launched aboard NASA's Orion spacecraft, lifted by the Space Launch System, the most powerful rocket NASA has ever built. At liftoff, it produces 8.8 million pounds of thrust. But this mission does not just loop around the moon, it flies thousands of miles beyond it, farther from Earth than any humans have ever traveled. But Artemis is not Apollo all over again. Apollo is about winning a race. Artemis is about building a future. The Artemis II crew is Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. Their mission is historic from the start. Cook is the first woman to travel to the moon, Glover the first black astronaut on a lunar mission, and Hansen the first Canadian assigned to one. That matters because this mission is not just about technology. It is about opening the next era of exploration to more of humanity. Over roughly 10 days, the crew will fly beyond the moon and return home, testing the systems NASA will need for future lunar landings. At the center of it all is Orion, NASA's deep space capsule. More advanced than Apollo in almost every way, more space, better safety systems, and technology built for long-distance missions. Attached to Orion is the European Service Module, which provides power, propulsion, oxygen, and water. Without it, the spacecraft cannot survive. After launch, the astronauts spent hours checking every major system before committing to deep space. Once NASA confirmed everything was working, Orion fired its engines and left Earth orbit for the moon. That is the moment everything changes. As the spacecraft heads farther from Earth, the crew moves through the harsh environment of deep space, facing greater radiation exposure and total dependence on their spacecraft. And then, Earth starts to shrink. Few people in history have seen our planet from that distance, a small blue world hanging alone in the darkness. Astronauts call the emotional impact of that view the overview effect. It changes how you see everything. Then comes one of the most dramatic moments of the mission. Orion swings behind the moon and temporarily loses communication with Earth. No mission control, no live contact, just silence. When the spacecraft emerges, the crew will see the lunar far side, a rugged, cratered landscape that almost no human has ever witnessed directly. And while Artemis II will not land, it is paving the way for where NASA wants to go next, the moon's south pole. That region may hold water ice inside permanently shadowed craters. And water is the key to everything: drinking water, breathable oxygen, and even rocket fuel. If NASA can learn to use those resources, the moon becomes more than a destination. It becomes a base, a supply station, and a stepping stone to Mars. That is the real goal of Artemis, not just to go back, but to build the skills and systems needed to live beyond Earth. After swinging beyond the moon, Orion will race home at around 25,000 miles per hour. Re-entry will be one of the most dangerous parts of the mission. The spacecraft's heat shield will face temperatures near 5,000 degrees Fahrenheit before parachutes deploy and the capsule splashes down in the Pacific. If all goes well, Artemis II will prove that NASA can safely send astronauts into deep space and bring them home again. And that is only the beginning. Future Artemis missions are designed to take the next steps, testing lunar landing equipment in Earth orbit, then landing astronauts near the lunar South Pole, sending robotic scouts, and eventually building a long-term human presence on and around the moon. Private companies are now a major part of that future. SpaceX and Blue Origin are developing human landers. Axiom Space is building the next generation of spacesuits. Robotic missions are already heading to the moon to test technology and search for resources. And America is not doing this alone. Canada, Europe, Japan, and many other nations are part of the Artemis effort. The United States is leading again in deep space, but this time with allies and private industry helping build something even bigger. And beyond the moon is the ultimate destination, Mars. The moon is where we learn how to survive far from Earth, how to use local resources, and how to prepare for the day humans finally make the journey to another planet. So the next time you look up at the moon, do not just see history. See the next step. See a training ground for Mars. See a future outpost. See the place where humanity begins its next chapter. We are living through the start of that chapter right now. We are the Artemis generation, and this time, we are not just going back. We are going farther.